everyone, and welcome to the last lesson of Activity 25, Lesson 25.4. Today we are actually not going to use the book, so you should either have the supplemental notes handout that is linked to the video in Google Classroom, or you should have a notebook ready to take notes if you are unable to print that out. You're also going to want a pencil and a calculator today. So on this note sheet, what we see here is that our learning targets are to talk about angles formed outside of the circle. So that's either going to occur when we have a secant that are meeting outside, and we have this angle A out here, a secant and a tangent, or when we have two tangents that are again meeting at the same point outside. So notice for all three examples, angle A is outside of the circle. We want to look at what the formula is going to be for this, okay? So basically what happens each time is we have an angle that's, or an arc that is far away from our angle outside of the circle, and we have an angle that is near that angle outside the circle. And what you're going to notice each time is that the far away arc minus the near arc is going to, and if we divide that value by 2, that difference, we're going to get the value of the angle. So arc KL is 174.95, ED is 61.92, and if we subtract big minus small or far minus near, and divide that value by 2, we get our missing angle measure, okay? And as we move around the circle, notice now we have a secant tangent example, same thing, we're getting that value, or when we have two tangents as well. I don't know if we can move on this. Oops, nope, doesn't look like we can move that, but oh, there we go. But we would see that these values, again, as we subtract far minus near and divide it by 2, we get that example. Okay, so the angle outside of the circle, so angle outside equals 1/2 of far arc minus near arc. Okay? And again, each time we're going to want to label this. When we talk about the far arc, it's the arc that's farther away from the angle. So in this case, this would be our far arc, far arc, and far arc. And our far arc is always going to be bigger than the near arc. Okay? And the near arc in each of these would be here, here, and here. Again, that's going to be our near arc, which is the smaller of the two values each time, because you need, when you subtract, for that angle to be a positive value. Okay, so that's why I was right far with big letters, so we know that that's the bigger number as well. Okay, so let's look at some examples. So x is our angle outside this time, and again, to find the value of our value of x, we're going to take far arc minus near, and 1/2 of 90 minus 30, which is 60. Half of 60 is 30 degrees. Next one, I want you to try on your own. Should have got for this one, since we have a far arc of 170, subtract away 40 from that, that's 130. Half of 130 is 65. Now this next one's a little bit tricky because we're looking for the angle again, but notice this time they give us the far arc, but not the near arc. Now we actually can find that value though, because we know that our near arc is always going to be 360 minus the far arc when it's a tangent problem, right? Because together these two arcs need to add up to be 360. So we know that this near arc, the smaller arc, would actually be 30 degrees when we subtract that. So 330 minus 30 is 300. Half of 300 is 150 degrees. Okay. Now on this next example, in example D, again, we need to do a little bit of work to find our far arc, because the near arc is actually given. The far arc is what we need to find here before we can find our value of x. So this time it would be 360 minus the 3 arcs we have of 106, 34, and 160. So that would be a value of 60 degrees when we do that. So then 1/2 of our far arc, which we said was 60, minus that near arc of 34, would be 1/2 of 60 minus 34, which is 26. So 13 degrees would be our angle outside. Again, on this next one, we need to find this near arc to be able to ultimately find the angle outside. So the far arc is 200, and then this near arc is going to be 360 minus the two arcs we have of 200 and 100. So 60 would be our remaining value there. And 1/2 of far minus near would be half of 140 degrees, so 70 degrees. And then last but not least, another one that is similar to example C, but this time we're missing our far arc, so we would have to do 360 minus 75 first, and that would leave us with a far arc measure of 285. And then to get that value of the angle outside, it's 1/2 of far minus near. So half of 185 minus 75, so half of 210 is 105 degrees. Now the next piece of this then is finding other pieces is looking at not only finding values for our angle outside, but then possibly other pieces like the arcs. So in this example, they gave us that we are looking for x when we have our far arc and our near arc. So again, 1/2 of far minus near, oops, it's 35. So 1/2 of 90 is going to be 45 degrees. But we get a little bit of a switch up in the next one, because what we're looking for this time is A, given that we have our angle is 35 and the near arc is 40. So on this one, now we have the angle. What we don't have is the far away arc. Okay. Now, a couple different ways you can solve this. Obviously, you can distribute the 1/2, but sometimes instead of distributing the 1/2, since there's nothing to cancel out with A, the quicker way to go about this is to multiply by 2 on both sides, because now we have 75 equals the pieces under the parentheses, or between the parentheses, A minus 40. Add the 40 to both sides. Oops, this is equal to 70, so sorry. Add the 40 across now. We end up with 110 as the measure of our angle. And when in doubt, you could always plug this back in. 110 minus 40 is 70, divided by 2 is 35. So it all checked out. Next one is asking us to find x if we know some other pieces yet again. So on this one, 160, C is 80, D is 70, and we want to find, again, our angle outside. So similar to what we had to do on the last page, the first thing we're going to have to do is figure out what our near arc is by subtracting from 360 the other 3 arcs that we do know, right? And together, those values would be 310, so our missing value is 50 here. Now we can take far minus near and subtract 1/2 of 160 minus 50 means it's half of 110, which is 55 degrees. Last but not least, we have a little bit of algebra involved. Okay, this time we're going to solve for t. They're telling us A is 10t, B is 3t minus 10, and our angle itself is 4t minus 1. So we know that that angle measure, 4t minus 1, is going to equal half of far arc minus near arc. Now be careful because we want to make sure we put parentheses around the 3t minus 10, since that subtraction sign will need to go to both pieces. So if we distribute that, we end up with 10t minus 3t plus 10, which means that inside of these parentheses, we actually have 7t's when we combine plus 10. Now, we've talked about it a couple times, but one good solution that if these aren't even numbers is you can always multiply by both sides, okay? So you can multiply the 1/2, you can multiply by 2. Now, if you choose to do that, if you go this route, if you don't distribute this and make this a 3, distribute this way, when you multiply by 2, again, the parentheses have to go around that left-hand side so that you can distribute. So you can do 8t minus 2 equals 7t plus 10. Subtract the 7t, we get 1t. And then we would add the 2 to both sides. So we end up with t equal to 12. Now another way you could have done this, right? Let's say you didn't want to subtract, right? Let's say you wanted to distribute. So we were at this piece, but we had 4t minus 1 equals 1/2 7t plus 10. You could have also distributed this. You just would have had to have been careful because this would have been 3.5t plus 5, because you're multiplying by 1/2, so you're dividing by 2. And then you would just have to be careful that you're dealing with a decimal. So when we subtract the 3.5t from 4, we're left with 0.5t minus 1 equals 5. Add the 1 to both sides. We have 0.5t equals 6. And when we divide 6 by 0.5, it's really the same as multiplying by 2. So we still get that answer of 12. Okay? Either way you decided to solve this. Okay? But that setup was the same to begin with on this. Okay, thanks everyone for watching. And again, we will work more with finding angles outside in class.